let's take a look at a pretty simple example. Now, you might say, okay, this isn't the most exciting example in the universe, but I think it really makes the essential point about what we need to consider when we're thinking about values in science. So suppose we've got a 12-inch ruler, and someone says, divide the ruler into 6 different pieces. How long is each piece going to be? So you say, okay, that's pretty straightforward. Each piece is going to be 2 inches. 12 divided by 6 is 2. Okay, that seems reasonable. Let's make it a little bit more interesting. Suppose your boss says, oh, no, I don't want 6 pieces. I want 8 pieces. Divide the 12-inch ruler into 8 pieces. How long is each piece going to be now? It's a slightly more interesting calculation. 12 divided by 8 is 1.5 inches. That still seems reasonable. 12 divided by 8. Okay, now what if instead of 6 pieces or 8 pieces, your boss says, actually, I want you to divide the ruler into 7 pieces. How long is each piece of the ruler going to be now? Let's take a look. 12 divided by 7 is 1.7142, this whole thing, okay? It goes on forever. It doesn't come out as a nice decimal number. Now, if you're in a maths class, you might say, well, 12 divided by 7, it really is this, okay? I have to write down the whole thing. But whenever you're doing science, whenever you're doing an experiment, this isn't just misleading, it's actually really incorrect, because in physics, any calculation we're doing, it's always grounded in something that we've actually measured. Let's take a look at this in a bit more detail here. So if you look at this huge number here, the size of an atom, it appears about over there. I've got a stick over here. Here we go. Okay, that's about the size of an atom over here. Okay. If we keep going somewhere over here, that's about the size of an atomic nucleus. And then if we keep going here, that's about the scale of what we call the Planck length. Now, the Planck length is the smallest physical size that it's possible to have in physics. It doesn't make any sense to talk about distances which are smaller than the Planck length. So the point that I want to make here is just because we've taken a 12-inch ruler and divided it into 7 parts, we don't know how small each part is to subatomic precision. We don't even know exactly that the ruler is going to be exactly perfectly 12 inches long in the first place, and then each part is going to be slightly different. So we always have to bear this in mind whenever we're doing a calculation. So clearly this huge number, it's kind of ridiculous. A more sensible result would just be, 12 divided by 7, it's going to be about 1.7 inches. So we don't get more precision than when we're looking at dividing the ruler into 6 parts or 8 parts. That's the fundamental idea that we need to bear in mind whenever we're doing any calculations. Does anybody have any questions at this point about this?